Beneath the thin atmosphere of Mars lies an enigma, a desert landscape shaped by flowing water. In the distant past, Mars must have had a warmer, wetter climate, but scientists wonder, just how wet was ancient Mars?
So in the ancient past, we have some indications that water was flowing on the surface, but how much water was there? We're talking about oceans, are we talking about small rivers, little rain? So these definitions of how much water was on the planet was very undefined.
A major question has been, how much water did Mars actually have when it was young, and how did it lose that water?
To answer this question, a team of researchers at NASA's Goddard Space Flight Center used infrared telescopes on Earth to study water molecules in the Martian atmosphere. The researchers found that water from the polar ice caps is highly enriched in deuterium, indicating that Mars has lost a tremendous quantity of water.
Now we know that Mars water is much more enriched than terrestrial ocean water in the heavy form of water, the deuterated form. Immediately, that permits us to estimate the amount of water Mars has lost since it was young.
The findings indicate that only 13% of an ancient ocean remains on the planet today, now stored in the polar ice caps. 87% of this ocean has been lost to space. This means that early Mars would have looked much different than it does today, with a significant portion of its surface covered by water.
This ocean had a maximum depth of around 5,000 feet or around 1 mile deep. It's deep, not as deep as the deepest points of our oceans, but comparable to the average depth of the Mediterranean Sea.
We now know that Mars was wet for a much longer time than we thought before. Curiosity shows it was wet for 1.5 billion years, already much longer than the period of time needed for life to develop on Earth. And now we see that Mars must have been wet for a period even longer.
It's fascinating that we can learn so much about 4.5 billion years ago with measurements taken right now. And ultimately we can conclude this idea of an ocean covering 20% of the planet, which opens the idea of habitability and the evolution of life on the planet.